This is the IDF exercise. I asked you to take a shot at it before watching the video and then turn it in after we go through it together. So it starts out in one weekend in Harrisburg. It rained 4 inches on Thursday and 5.7 inches on Friday. This actually happened, by the way. These are real numbers from several years ago. Use the attached tables and IDF graphs to answer the following questions. What are the frequencies of these 24-hour storms? We got a 4-incher and a 5.7-incher. So if I go down here at 24 hours, which is 360 minutes would be 6 hours. So I don't have that on the graph there. But if I go down here, I have 1440 minutes. That's 24 hours. So the first one Thursday was 4 inches. So that's centimeters. So I get down here inches. So 4 inches would be right in here. So that's a little above 5, below 10, maybe 6 years. And the other one was 5.7. So 25 years, 5.6. The 50 years, 6.5. So it's somewhere in there. I might say, I don't know, 27 years. So those are two big storms. So I'm going to say about 6 years on this one and about 27 years on this one. What is the probability of a 24-hour storm of 5.7 inches or more happening in a given year? Well, if you remember, the probability is just the inverse of the return period. So it would be, probability would be 1 over 27, which works out to about 3.6%. If the Friday rainfall were the same as the Thursday rainfall, which day would produce more runoff? Well, on Friday, the ground is already wet. So what happens when it rains, it starts filling up the storage of the site, the water it can store, including the initial abstraction, which is estimated as 20% of the storage. That would be filled before any runoff happens. On Thursday, it got all wet. So Friday, it will just start running off right away. So the Friday, and we might say because the existing conditions or sometimes the antecedent, did I spell that right? Conditions. So the site is already wet. Now our simple methods that we'll do for runoff do not take this into account. There are some methods and some models that you can do that will take that into account, but it will definitely run off more on Friday because it's already wet, so it can't hold any more water, so it's pretty much all going to run off. What would you estimate would be the frequency of the 48-hour storm? So these two put together. Now we don't have in here, that goes up to 6 hours, this goes up to 24 hours. And generally we don't keep track of this beyond 24 hours. I don't think, I haven't seen the statistics on that. But we have a 1 in 6 chance of having a storm that big one day and a 1 out of 27 chance of having a storm that big on the next day. So maybe 2 of those storms together be 1/6 times 1/27. That would be the probability. Not really, but the point is that you had a rare event on Thursday and a rare event on Friday. And so both those happening, the probability of both those is going to be less than the probability of either one. Do you follow that? And you also, but you can't, I also teach statistics, and you would take the probability of one times the probability of the other. But you have something here, you have serial correlation. So if raining one day is more likely to rain the next day. If it's hot one day, it's more likely to be hot the next day. So these are not really independent events. That's not the point of this. The point is that, I don't know, 50 years, is that two rare events together, the probability of that is going to be less than the probability of either one of those. The Thursday rain broke a 119-year-old record for October 10th. Therefore, it was greater than the 100-year storm. Right? Why or why not? So, well, I'll just give you the answer. No, that's not right. The 100-year storm is based on the largest storm of the year, not on a certain date. Just like it would be saying that this is the coldest July day in 50 years is not the same as saying this is the coldest day of any day of the year in 50 years. So you could have rainy and cool seasons. So anyway, that's not true. It's the data, the frequency is built on the biggest one of the year, not the biggest one for that particular date. During the peak of the storm, it rained 1.3 inches in 20 minutes. What is the intensity during this period? Intensity, if we look here, our intensities are inches per hour, the units we tend to use, or millimeter or centimeters. These are, by the way, our totals. So we only want this in inches per hour. So it would be 1.3 inches in 20 minutes, but it's over 60 minutes per hour. So 3.9. So in other words, 1.3 inches in 20 minutes times 3 would be at a rate of 3.9 inches per hour. What is the frequency during the 20-minute peak period? Also show graphically on the IDF graphs. So we'll go down here. So what do we have? 1.3 inches in 20 minutes, which we said was 3.9 inches per hour. So we go up here, 1, 2, 3, about up to 4, and 10, 15, this has got to be 20 minutes here, right? We go up here, and it's looks like this diamond one here is the 10-year, and the next one up is the 25-year. So it's past the 10, before the 25. This is a log scale, so actually the 9 would be very close to the line there. I'm going to say that's 20 minutes. So this is the 5. This is the 10. This is the 25. You can't read that, but I'm going to say that's about 20 minutes. I'm sorry, 20 years. That's the frequency. What about in my table here? Between 15 and 30, I had a total of 1.3. So somewhere in here, in 20 minutes, I had a 1.3. Again, it's between the 15 and the 30, and between the 25 and the 50. So somewhere in there, I would also get about a 20-year return period if I wanted to do it that way. What is the 20-minute, 100-year rainfall intensity? 20-minute, 100 years, the top one there. That looks like it's right at, what number is that? 2, 3, 4, 5. Looks like it's right at 5 inches per hour. What is the 20-minute, 100-year rainfall? Well, the intensity is 5 inches per hour times 20 minutes, or 1/3 of an hour, 1.67 inches. And let's check that with, again, our table here. Our chart is intensity. Our table is the total rainfall. So 100-year, 20 minute is going to be somewhere between the 15 and the 30, so somewhere between 1.44 and 2.09. So that lines up with what we calculated from our graph. By the way, this one also shows the rainfall amount. So we can do that from the table, or we can do that from this figure. So 20-minute, 100-year. It's hard to interpolate off a log scale, but that pretty much matches up with our 1.67. All right, so turning the scan of that was a little exercise in using these IDF curves and the tables.